Hello, ladies and gentlemen. Today we are continuing on in Unit 4 here, talking about piecewise functions. So for our work today, you're going to need your notes, maybe a calculator would be handy, and something to write with. So our learning target today is that if we're given a piecewise function, you can evaluate for a specific x value. This is where your calculator comes in handy and understanding how piecewise functions work. So the first part we need to write in your notes is the actual definition of what it means to be a piecewise function. We may have taken a look at this just a little bit in terms of an introduction, but the formal definition, just in the blue box, needs to go in your notes. A piecewise function is made up of pieces of different functions which are a result of their different domains or x values. So a piecewise function is one function that's made up of many different parts, and the parts are divided based on their x value. So one way to look at this in real life, you don't need to write down the real life example part here, but in real life, most of our functions are piecewise functions. In fact, if you have a job, it is a piecewise function to figure out how much you're going to be paid. So in real life at your job, let's say you make $8.50 per hour up to 40 hours. But then after 40 hours, we have laws that say you should make time and a half. So at 40 hours, we switch the way we calculate your pay to a new function. What this would look like is that we would say, well, your pay is going to be $8.50 times your hours for hours 40 or less, but once you go over 40 hours, time and a half, or 1.5 times 8.5, gives you $12.75 per hour you'd be making if you worked over 40 hours for all those hours that are over 40. So we would take this and write it in math notation. So in math notation, notice that we have one y equals, right? But we have two parts that make up this function. The first part is $8.50 x, and then there's a comma, and then it says for x values less than or equal to 40. See that part right here? There's a comma right here that says this tells me when I'm going to use this part of our equation. But once my time goes over 40 hours, then I'm going to get paid based on $12.75 per hour. So there's two lines here, or two parts, that make up one function to determine your pay. We switch calculations based on the number of hours you worked. And at 40 hours, the function switches. So our work today is going to be interpreting this idea. So in your notes, please write down the example 1 here. We're going to just be working on evaluating piecewise functions today. So we have the first part of this function is 2 times the absolute value of x plus 4 minus 2. We know that this would be a v, right, because it has that absolute value. And then there's a comma, and it says if, sometimes the if is there, sometimes it isn't, x is less than 3. And then there's another part to the function that says use 1/2 x plus 1 if x is greater than or equal to 3. So if we need to find these three things down here, find, this is a fancy way of asking us to substitute in these x values. So it says find f of 5. Remember, sometimes this will be labeled with an f of x, naming the function, if you will, but the function is made up of two parts. It says find f of 5. 5 is the x value. So that means I'm going to plug in the number 5, but I don't plug it into both parts. I only plug it into where it's appropriate. This part says if the x value is less than 3, I'm going to plug it in here. This part says if the x value is greater than or equal to 3, I'm going to plug it in here. So because 5 is greater than or equal to 3, that means I'm just going to plug him into the bottom part. So I'll take 1/2 times 5 plus 1. And so I'll go to my calculator. 1/2 times 5 is 2.5 plus 1 is 3.5. You can turn it into a decimal if you would like. And that'd be my final answer. So f of 5 is 3.5. Now what about -4? If I were going to plug in a -4 for an x value, which one would that fall into, the top line or the bottom one? Well, the top function part here says if x is less than 3, I'm going to plug it in there. And -4 is less than 3. So I'll just plug it into the top part. So I'll have two absolute value, -4 plus 4, shut the absolute value here, and then minus 2. So if I go to do my calculations, negative 4 plus 4 is 0. The absolute value of 0 is still 0. Times the 2 in front, still 0, minus 2, negative 2. So using mental math, calculators, whatever you need, we're just finding that value after we plug it into the appropriate piece. Now what if the x value is 3? Now both of these have a mention of 3, but notice the second one says if x is greater than or equal to 3, we're going to use that one. So we're going to plug it into the 1/2 plus 1. So 1/2 times 3 is 1.5 plus 1 is 2.5. So we're evaluating based on the x value. Which part are we going to plug it into? Okay, let's look at another example. This one has 3 parts. So given this piecewise function, it says f of x equals 2x squared plus 1 if the x values are less than 4. Or you use 4x plus 2/3 if the x values are less than 7 but greater than or equal to 4. So basically between that 4 and that 7, including the 4 in this second one. And then it's just 3. Notice there's no x here if x is greater than or equal to 7. So let's find the first one. It says find f of negative 2. That means plug in negative 2 for an x value. So where would I plug that? Into the top part, the middle part, or the bottom part? Well, the top piece says if x's are less than 4, that's the one I'm going to use. And because the negative 2 is less than the 4, yep, that's the part that I want to use. So I'm going to plug it in there. So it's 2, negative 2 goes in parentheses so I can square it, and then plus 1. Now when you go to calculate this, be very careful. You need to put parentheses around that number you're plugging in because we need to square it first. So negative 2 squared times itself becomes positive 4. Times 2 is 8, plus 1 more makes 9. So the value then of that function piece there would be 9. Now let's do f of 8. Well, 8, what part is that going to plug into? It says use the middle part if the x values are between 7 and 4. It says use the last part if the x value you're plugging in is greater than or equal to 7. Well, 8 is greater than or equal to 7, so I'm going to plug it in this bottom part here. Now notice when I go to write it, it's 3, but then there's no x here, right? There's no x, there's no place for me to plug the 8. So it just stays 3. 3, no 3 times x, no 3 plus x, just 3. Okay, it's a constant. No matter what x value, it's just going to be 3. Let's do the last one. What if f of x, what if we want to calculate the value for 4? Now 4 is mentioned in 2 pieces here, the top one and the middle one. But because the middle one says you want to use it if x is, notice the little equal bar here, are equal to 4, that means that's the one I'm going to plug it into. So 4 times 4 plus 2/3, that'd be 16 plus 2/3 more, 16 and 2/3. If you like the whole idea of turning it into a decimal, you'd say approximately or exactly 16.6 repeating. Okay, you could do that. You could make sure you put the repeating bar there if you want to do that. You could round 16.7 if you want to. Okay, this would be exact with the decimal fraction bar there, or repeating bar. So we are plugging in each little part. Now the last example we need is what if we already have a graph of this thing made and we don't have the 3 equations? Well, we can still do the same idea, understanding that these are x values. So if I want to find the value, if f of x equals negative 6, then that means this is the x value I'm looking at. So x value, negative 6, you're right here, right? This spot. Okay, well, what is the value of the function at that spot? Well, I'd have to look up and read that part of my graph. So what's happening right there? My y value, if I read across, would be 5. So my value of my function would be 5 at the x value of negative 6. What if I have f of 1? Well, here's the x value of 1 right here, okay? Now if I look up, I have a spot there. I also look down and I see a spot there. Notice that the one on the bottom is an open circle. That means there's not really a number there that we should be looking for. Okay, it's not a valid part of our function. But if we look up, I see a closed circle here. That means this is a point that we need to talk about. This is the point 1, 3. So the value of my function when x is 1 would be 3. That's the y value that corresponds with it. What about negative 1? Let's look at negative 1 on the x-axis. Negative 1 would be right here. Looking down, I have a spot here. Looking up, I don't have any spots, so this is the only y value that I'm looking for. The y value there would be negative 7. So in some ways, reading the graph is a little bit easier than actually having to do the calculations with the function equations. Okay, so that was our first lesson goal here, guys, evaluating piecewise functions. I want to thank you for taking good notes.